Okay, now to get into the fun stuff, rational exponents. By rational, I mean that we're going to have some fractional exponents. So I want to start you off with these two problems right here. So what we know based on some of the rules already for rational exponents is this. So we know this. We know that a power to a power rule means we multiply. So if I take 7 and I say 1/2 times 2, well, you should be able to do that. 7 to the first power. So we know that's 7. Now take a look at this one. We take a look at this one, we know this is square root of 7 times the square root of 7. But that's another way to express root 7 to the second power. And we know that one too. We know that that's going to turn out to be root 49, which is just simplified to 7. But look, they equal the same thing. So when we say root 7, we are really saying 7 is to the first power, and the root is 2. And another way to express that is 7 to the 1/2. Our 1 being the power in the radicand, and our 2 being the index. And we can look at some other problems just like that give us the same idea. So if I said 64 to the half, to the 1/2 power, well, all I'm really saying is root, that's root 2, 64 to the first. So I've taken the 1, the numerator, and the denominator, another way to think about it, this being the numerator, of the rational exponent, and this being the denominator. Noteworthy, unless you've already got that. And as we take that, well, we really see it like this. By convention, we don't write the 1 and the 2. So we got to know that root 64 is the same as this root 2, 64 to the first power. And we know how to take the square root of 64, just gives us 8. So 64 to the 1/2 power is the same as root 64, square root 64. Let's take another example. If we have 125 to the 1/3, well, what does that look like? You might want to pause to think about it before I give it to you. So we can say that that is going to be the third root of 125 to the first power. Now, by convention, we're not going to write that 1, so you've got to notice it as third root of 125. Well, what number to the third power gives us 125? 5. 5 times 5 is 25 times 5 again, because it's third root, it's 125. So we got to see and we got to recognize that this is the same as this rational exponent. Another way to express it. Here's another cool idea. Negative 27 to the 1/3 power. So we could say, all right, well, what does that look like? Well, that looks like radical 27, but that's got to be to the negative 27. Now, normally we'd look at that and say, well, we're not going to get a real number. But in this case, the index is 3 because the denominator is 3. So I can evaluate that because there is a number that gives us negative 27. We say negative 3 times negative 3, that's positive 9, times negative 3, well, that gives me negative 27. So the number that we can multiply 3 times is negative 3. So we can evaluate this problem because the index is odd. So the index is an odd power. Maybe there's a rule there. Let's look at another one. How about this? 27 to the 2/3. That's irrational. Exponent is 2/3. And what is that going to look like? Try to write it out before I do. Pause it. Draw my radical. Now I know denominator is 3, so that's the index. 27 is what I have in there, and that's the same as cube root of 27 to the second power. Which means I can evaluate this because I know 3 times 3 is 9 times 3 is 27, so I know that's 3 squared. I can simplify that pretty quickly, and it's going to come out to 9. So we can simplify that down to, okay, 27 to the 2/3 power is just equal to 9. So that's one way to think about it. Another way to think about it is this way, and this is the way I tend to like to see it, just because it follows my directions over here on the left about numerator, denominator. So I've always thought about it like this. I rewrite it, it's the cube root of 27, and I can say that's squared. So 27 squared, all right, that's nothing I'm going to do mentally, but that gives me 729. So if I take the cube root of 729, there's a couple keystrokes you can do on a calculator. So the first thing you would do on a scientific calculator is, what you could do is you would take the 729, scratch that, we're going to say graphing calculator. So if I type in and then I take this problem, I can easily do this on the graphing calculator, but it's also good to know the rules. But if I do 27 and I raise it to the power, so there's that key in the graphing calculator that looks like the caret, and parenthesis, I type in a 2 divided by 3, close the parenthesis. These are just key boxes. I guess I should put a box around these as well. But on a graphing calculator, you could take that and evaluate it as such. And we'll see that that comes out to 9. Because 9 times 9 times 9 gives you 729. And that's the way you could evaluate. Now, we're looking at these because I wanted to look at numbers that are in the rational exponent that are, a is greater than 1. Because we've been dealing with 1 on the other problems. Here's where the real fun begins. And we can simplify these. So you got to use a lot of properties now. Properties and things that we've been practicing and putting them together. So we're all building. All this stuff is building one on top of another. For this, we already know we would take 3 times 4. And these are just, exponents, but they're rational exponents. So they follow the same rules. So we've got x to the 2/3 times x to the 3/4. First part's easy, right? 3 times 4 is 12, mentally. That's easy. Now x, well, what's the rule? Like bases, we're multiplying bases. What do we do with the exponents? You should have answered to yourself or out loud. We add them. So we've got to have some thoughts about our fractions again. So 12x. Now what's going to be, well, I can't add those the way they are, so I have to have like denominators. I'm going to change that first one to something over 12 plus something over 12. Seems to be the common denominator. 3, 4, that's going to be 8. And then this other one, multiply 3, we get 9. Now I've got a common denominator, and I can add these. 12x to the 17/12. And that's simplified. That's all that type of problem is asking you to do. Bump it up. So we've got 2y to the 1/5. So that's a fifth root of y, whatever that is. And then we've got that raised to the 4th. So remember, you have to take 2 to the 4th. That's, after a while, that's going to be something that is probably a common mistake. And then we have 1/5 raised to the 4th power. So the power rule applies here. So we have y, and we have to take 1/5 times 4, which isn't really too bad to do that. We're just going to say y to the 3/10 on the denominator for now. 2 to the 4th is 16. And then we're going to have y to the 4/5. That's not a bad multiplication. It's just the fact of doing it. Y to the 3/10. Oh, now we have the quotient rule. So we've got 16y, and we have 4/5 minus 3/10. Not as bad as it could have been, right? So remember, the quotient rule tells us we can take the numerator's exponent minus the denominator's exponent. And that's what we're doing. So that's why you see nothing in the denominator right now. So 16y, I'm going to change that to tenths. So I've got 8/10 is the same as 4/5, 3/10. And we're going to look at 16y, we got 5/10, which is nice because that's not a 6, that's a 10. We have 16y to the 1/2. Or, what is 1/2 power? 16 root y. That's a simplified version. And I should take care of some examples and give you a little bit to get started with all of the problems. So we've covered everything in P3 as far as being able to apply some of these and practice them.